Good morning. I'm Dr. J.L. Divyashivani from CSE department. Today we are going to discuss about digital computer. So we are going to discuss about three topics today. One is digital computer. We are going to discuss about analog computer versus digital computer. Next we are going to discuss about the components of computer. So these three topics are very important topics of computer organization and architecture, Unit 1. So first of all, what is a computer? So computer is nothing but it is an electronic device which performs operations, and we take the inputs from the user gives the input, the computer processes it and gives the output back to the user. So whatever inputs that we are giving to the computer are in the form of a program. So what is a program? Program is nothing but it is set of instructions. Set of instructions. Each instruction consists of operation to be performed and operands. Operation and operands. So this is about computer in brief. That is, computer is nothing but it is a electronic device. It takes input from the user, it processes the input and it gives output back to the user. So program is nothing but we can interact with computer in the language that it knows, and that interaction is called as a program. And program is nothing but it is set of instructions, and each instruction consists of operands and operation to be performed. This is about computer. Now let's look into the block diagram of computer. So first of all, this is nothing but, so this is nothing but CPU. In CPU we have ALU, that is arithmetic logical unit, and control unit. And we have input devices and output devices. And there is memory also. There is memory also in it. So what are input devices? Whatever information I want to give to the computer, I am giving in the form of instructions, that is program. So for giving that instructions, I require input devices. Some of the input devices that we are using are mouse, keyboard, we are using mouse, keyboard, as well as speakers also. Okay, coming to CPU is nothing but central processing unit. It is nothing but it is the heart of the computer. It consists of arithmetic logical unit and control unit. So what is arithmetic logical unit? The name itself says that it performs arithmetic operations as well as logical operations. So when I say arithmetic operations, we think of subtraction, addition, multiplication and division. So these are the arithmetic operations, and logical operations are and, or, not, NAND, NOR, XOR and so on. And control unit is nothing but it controls the operation of complete computer. That is not only the ALU and CPU, it controls the operation of the computer as a whole. And control unit also plays a major role in processing the instructions. And in ALU we have some, and one more important thing is nothing but memory. Memory is nothing but, we know what is memory. Memory is nothing but some storage device. Memory is a storage device. So there are various kinds of memories. So we will be reading about various kinds of memories. So memory, actually it is used to store data, it is used to fetch data, and it is also used to store data permanently and also temporarily. So we will be discussing about arithmetic logical unit and memory in detail. And output devices are nothing but the output after processing should be given to the user. So example of output devices are nothing but monitor, speakers, and so on. Okay, so now we are going to discuss about memory, and control unit in detail. So once let us look into the block diagram of computer. Input devices, CPU, which is called as heart of computer. It consists of ALU and control unit. ALU is nothing but arithmetic logical unit used to perform arithmetic and logical operations. And we have output devices, that is monitors, speakers, and so on. And we also have memory connected. So we are going to now look into ALU and memory in detail. So computer, like there are many languages. We are used to we use languages to communicate with each other. Okay, there are many languages that we use, like English, Telugu, Hindi, etc. But computer cannot understand all these languages. It can understand only one language, that is binary language. So what is a binary language? Binary is nothing but it is zero. It understands only zeros and ones. So initially we are giving data to the computer. So if we are giving data only, the computer can work with the data. So what are the kinds of data that which we can give? It is data can be in the form of text, it can be in the form of audio clip, it can be in the form of video clip, or it can be an image also. So all this, whatever we are giving, let it be text, let it be audio, let it be video, or let it be image, this is converted into zeros and ones, and then only the computer can work with it. Again, after processing, after performing the operations using ALU, it again gives the result also in the form of binary. Okay, it gives us the result in the form of binary. So binary result, if I give a image as input, and if I am getting some output like 10100, so the user cannot understand this, right? So then what we do, we use a decoder, and decode with the help of decoder we convert this binary back into the normal format that the user has given, and we give them the output. Here in ALU, decoder and encoder plays major role. So whatever language we are giving the instructions, that is, let it be C, Java, Python, or whatever language we are giving, or Python, we are giving instructions to the computer. With the help of encoder, it converts the given instructions into zeros and ones, and then after processing, again we get the result in binary form, which is again converted back with the help of decoder into the original format that the user has given. Suppose the user has given input as text, he will get the output as text. If the user has given audio as text, he will get audio as output. Video as input, he will get video output. And similarly, image also, if he is giving as input, he will get image as output. This is about ALU. So what are the various operations? So now we are going to deal with ones and zeros only. So let's look into arithmetic operations. So let's look into arithmetic operations, that is addition, subtraction, multiplication and division. Now let's take some inputs A, B and C. C is nothing but A plus B. Next, D is nothing but A minus B. Next, E is nothing but A into B. And F is nothing but A by B. Now let us take the values of A and B. 0, 0, 0, 1, 1, 0, 1, 1. So C is equal to A plus B, that is 0 and 0 gives me 0. And A plus B, here I will have sum and carry. So here 0 plus 0 produces a sum 0 and there is no carry produced. 0 and 1 produces a sum 1 and no carry is produced here. 1 and 0 also produces sum 1 and there is no carry produced here. 1 and 1 gives me 2, that is 1 0. Okay, then here the sum is 0 and carry is 1. Similarly, A minus B. So we require here difference as well as borrow. 0 minus 0 is nothing but 0 and borrow also is 0. 0 minus 1 is not possible. So I will take borrow 1. So when I take borrow 1, this becomes 1 0, that is 2. 2 minus 1 gives me 1. So the difference is 1. 1 minus 0, the difference is 1 and borrow is 0. 1 minus 1, difference is 0 and borrow is 0. Similarly, A into B. 0 into 0 gives me 0. 0 into 1 gives me 0. 1 into 0 gives me 0 and 1 into 1 gives me 1. Next is A by B, that is division. 0 divided by 0 gives me 0. 0 divided by 1 is infinity. Next, 0 divided by 1 is 0. 1 divided by 0 is infinity. And 1 divided by 1 is 1. So this is about the arithmetic operations that are performed in computer in binary format. Now we will look into the logical operations. Logical operations. When we say logical operation, we talk about the gates. So basic gates are so what are the basic gates? We have AND, OR and NOT. These are the basic gates. So let's look into the gates. So AND is nothing but, it is denoted by, this is the gate that we are using for AND. So we can have n number of inputs and only one output. And AND is nothing but A into B. So here I will take inputs as AB and A and B. 0 0, 0 1, 1 0, 1 1. So AND is nothing but A and B means nothing but A into B. 0 into 0 will give me 0, 0 into 1 0, 1 into 0 is 0 and 1 into 1 is 1. So only it is high only when both the inputs are, output is high only if both the inputs are high. This is about AND gate. Now let's look into OR gate. Here in AND gate we can have n number of inputs and only one output. Let us look into OR gate. So this is a OR gate. So OR gate is nothing but A plus B. Zero zero, 0 1, 1 0, 1 1. So only for 0 0 it gives me 0. All the others it gives me 1. So this is OR gate. So I can say that the output is high if either output is high if at least one of the inputs are high. Output is high if at least one of the inputs are high. This is about the OR gate. OR gate also can have n number of inputs and it has only one output. Now let's talk about NOT gate. NOT gate has only, this is also called as complement. So if I am giving A as input, A bar is nothing but it is the complement or it is NOT gate. NOT gate or complement. So here in NOT gate I can give only one input, that is A, and I get only one output. So A and A bar. If I give 0 I get it as 1. If I give 1 I get it as 0. So these are the three basic logical gates. Now we will look into other gates, that is NAND, combinational gates. These are combinational gates: NAND, NOR, XOR and XNOR. Okay, NAND gate is nothing but it is a combination of AND gate and NOT gate. NOR gate is nothing but it is a combination of OR gate and NOT gate. Similarly, XOR is nothing but A XOR B, that is AB bar plus A bar B. Similarly, XNOR is nothing but XOR gate plus NAND gate plus NOT gate. Okay, so basic gates are, we have three basic gates, that is AND, OR and NOT. AND is nothing but the output is high if and only if both inputs are high, and OR gate is nothing but the output is high if and only if at least one input or both the inputs are high, and NOT gate is nothing but whatever we give, if we give 0 it gives us 1, and if we give 1 it gives us 0, it gives us the complements. So these are the basic gates and these are the combinational gates or the special gates, that is NAND gate, NOR gate, XOR gate and XNOR gate. Let's look into the combinational gates. So what is NAND gate? NAND is nothing but AND plus NOT gate gives me NAND gate. So AND gate. First let us draw AND gate. This is AND gate plus NOT gate. So this is NOT gate. Okay. Here I will give the inputs A, B. This also can have n number of inputs and only one output. So this can be redrawn as this form. So A, B and Y. Y is nothing but A into B bar. So now let us write the truth table for this. A, B, A and B, A and B. So let us take the input 0 0, 0 1, 1 0 and 1 1. So multiplication we get it as 0 0 0 and 1. So next, because it is NAND, so first this is and NAND will be 111 and 0, that is complement of this. So what I can say, what I can define the result as the input, if the output is low if and only if both the inputs are high. Okay, output is low if and only if both inputs are high. So if both inputs are high, the output will be low. Now let's look into NOR gate. NOR gate is nothing but it is a combination of NOT gate and OR gate. So let's draw the OR gate first. So this is OR gate and NOT gate. So this also can have n number of inputs and it produces one output. So this can be redrawn as like this. Okay. Now let's write the truth table for this. A, B, A or B, A nor B. 0 0, 0 1, 1 0, 1 1. OR means addition. So 0, 111. And NOR is nothing but complement of OR. We get it as 1 000. So we can say, we can conclude about NOR gate that the output is high if and only if both the inputs are low. Output is high if both inputs are low. Okay, output is high if and only if both the inputs are low. This is about NOR gate. NOR gate also can have n number of inputs and only one output. Now let's look into XOR gate. XOR gate is a special kind of gate. So this also can have n number of inputs and it produces only one output. XOR is given by, the symbol of XOR gate is this. This is a symbol of XOR gate. So here XOR gate also can have n number of inputs and produces one output, and this A XOR B means A bar B plus AB bar. Let's draw the truth table for this. A, B, A bar, B bar, A bar B, AB bar, A XOR B. So this is nothing but 0 0, 0 1, 1 0, 1 1. A bar means we know it is complement. So 0 0 changes to 1 1 and 1 1 changes to 0 0. Similarly, B bar will be 1 0, 1 0. A bar B. So we are going to multiply these two things. So what do I get? 0 into 1 is 0. 1 into 1 is 1. 0 into 0 is 0. 1 into 0 is 0. AB bar. Now I'll multiply first column and fourth column. What do I get? 0 into 1 is 0. 0 into 0 is 0. 1 into 1 is 1. 1 into 0 is 0. Now I need to add up these two columns. So what do I get? 0, 1, 1 and 0. This is nothing but A XOR B. So this is about A XOR B. So when I want to talk about A XNOR B, then what do? I attach a NAND gate to this. So what will the answer be? A XNOR B, that is 1 0 0 1. So today we have discussed about arithmetic operations and logical operations of binary numbers. Arithmetic and logical operations of binary numbers. So when we talk about binary numbers, we know that we have only two symbols in binary numbers, that is 0 and 1. Now let's talk about, let us switch back to the topic. So we have discussed about ALU, we have discussed about input devices, we have discussed about output devices, we have discussed about control unit, and ALU, these comes as CPU and memory. Now let's discuss about memory. So memory means what? Something we want to store, or we want to fetch some stored information, we access memory. So memory is used for storing and accessing data. So what are the various kinds of memory? So firstly we have primary memory. Next we have secondary memory. Next we have cache memory and registers. So now primary memory is nothing but inbuilt memory. So now the example for primary memory is the mobile phones, the latest mobile phones that we are using now. The latest mobile phones that we are using now has inbuilt memory in it. Okay, previous mobiles we were using SD cards, that is for storing data we were using SD cards, but now we are using phones with inbuilt memory. So primary memory is nothing but inbuilt or internal memory. Secondary memory is nothing but it is the additional memory that is connected. Additional memory or external memory that is connected. And cache memory is nothing but it is a replica of main memory. And registers are nothing but these are temporary storage devices. Yes, so this is about memory. So we will look into detail about what is primary memory, what is secondary memory, cache memory and registers. So what is primary memory? Primary memory and secondary memory. Primary memory is inbuilt memory. Because it is inbuilt, it can be accessed easily. Speed will be more, cost will be more. So we can just think of our iPhone like 64. So we can think of iPhone like if it is 64 KB or 128 KB. The price varies because the price varies a lot because it has internally or inbuilt memory, and secondary memory is nothing but externally connected memory like SD cards. We can also say the example is hard disk. Hard disk also is a externally connected memory. Hard disk also is a externally connected memory, and accessing this memory is very difficult. That is directly our processor cannot access secondary memory directly. First, the contents of secondary memory are stored into the main memory, and from main memory the processing is done. So so many steps need to be followed, that if it is internal memory, directly the processor can access it. But if it is external memory, first the contents are loaded into the internal memory, and from that accessing is done. So it is slow when compared to inbuilt memory. The price also is less when compared to inbuilt memory. So next we are going to talk about registers. So registers are nothing but these are temporary storage devices. So each register can store only one bit, that is either 0 or 1. So the register will be of this form. It can store either 0 or 1. So the registers are located in ALU. In ALU, suppose I give a instruction add AX comma BX. So here AX is a register and BX is a register. So it will go to AX, register AX, and it will check if I have 0 1 here and 0 0 in BX. So first what the processor does when we give this instruction, so here we are giving the operands in form of registers. And this is the operation to be performed. So what the processor does, first it goes to the memory, the register AX, fetches the data from there, that is 0 1 and 0 0, and then it performs the operation on this. So registers are nothing but these are temporary storage devices used to store only one bit. And when I say temporary storage devices, first I give my instruction as add AX comma BX. Next I give subtract AX comma BX. So after performing this addition instruction, AX will store the output of this addition instruction. Next, when I go to subtraction instruction, what happens? The previous data is deleted and new data is loaded. Suppose if I want to go back and look into the previous operation results, it is not possible in the registers. So maximum we have 8-bit registers, 16-bit registers and 32-bit registers, not more than that. Okay, so these are temporary storage devices. Now we will look into types of registers. So what are the types of registers? First, accumulator, data registers, accumulator, data registers, stack pointer, instruction, pointer register, and flags or special purpose registers. So, what are data registers? Now, if I give some instruction like move ax comma 05. So, already in register ax, I have some value 0. Now, I need to move this value 05 into ax. Now, ax is loaded with 05. So, here data registers are nothing but they are used to store the data or operands. Next, accumulator is nothing but it is used to hold the result. Next, stack pointer. Now let us talk about stack. Stack is nothing but suppose I am giving 100 instructions in a program. Okay, 100 instructions in a program. So, what the processor does, it goes to the program and it fetches the processor. What it does, it fetches the instructions one by one. When it is performing first instruction, after performing first instruction, it goes to the second instruction. After performing second, it goes to the third instruction. Like that it takes place. So normally, we are having something called as stack. This is used to speed up the processor. So how it speeds up the processor? So we have 6 byte stack, 12 byte stack, like that. So mostly used is 6 bytes. So what the processor does is like instead of going and interfacing with the program, instead of going and interface, what the stack pointer does is, instead of going and interfacing with the program, it accesses stack. So stack is nothing but 1, 2, 3, 4, 5, 6 instructions are stored. So instruction register, whenever the processor is working with the instruction, so first instruction, suppose the processor is working with first instruction, so it is loaded into instruction register. Then the second instruction comes into the place of the first instruction. Third, fourth, fifth, sixth and seventh instruction is loaded into stack. With the help of stack, what happens? We are speeding up the processor. So this is about stack pointer holds the address of top of stack. Address of top of stack. And instruction register, it is used to hold the current instruction under execution. Next, let us talk about, so now we have discussed about data registers, accumulator, stack pointer, as well as instruction register. We are only left with flags. So flags are nothing but these are special kind of registers. By looking at flag registers, we can say what the output of the ALU operation is. So we have something called as zero flag, interrupt flag, sign flag, parity flag, overflow flag, carry flag, auxiliary flag. So after performing, when ALU is performing operations, if the result is 0, if the result produced in the ALU operation is 0, then 0 flag is set to 1, else it is set to 0. And what is interrupt flag? If interrupt is produced, or enabled, it is set to 1, else it is set to 0. Sign flag, positive means 0 and negative is 1. Parity flag, by looking at parity flag, we can say whether if it is 0, we will say it is odd parity, odd number is produced, and if it is 1, we will say even number is produced. Overflow flag, suppose I am working on 4-bit numbers. Suppose I am adding or multiplying 4-bit numbers and the result produced is of 5 bits. Then the overflow flag is set to 1. Carry flag, if carry is produced, it is set to 1. Auxiliary flag is nothing but, so before talking about auxiliary flag, let us talk about the concept of bits, bytes. Bits, bytes and nibbles. Either 0 or 1 is called as a bit, 4 bits is called as a nibble, and 8 bits is called as a byte. So here, if I am working on a 32-bit number, in one of the nibble, if carry is produced, then if at least in one of the nibble the carry is produced, then this auxiliary flag is set to 1. So by looking at the flags, we can, instead of looking at the result, by looking at the flag only, we can registers only, we can guess what the result of the ALU operation might be. So we have discussed about registers. In registers, we have discussed about general purpose registers, data registers, flag registers, stack pointer and instruction registers. So let's just have a quick review of what we discussed today. We spoke about what is a digital computer. Next, we spoke about the block diagram. And next, about each component in detail. We have spoken about registers, and we also spoke about memory. So these are the topics that we discussed today, and in the exam we can expect few questions like 5 marks or 10 marks questions. Usually they will ask us to write about register format. So when they are asking about register format, we need to write about all the kinds of registers. Take examples and write about all the kinds of registers. If they are asking block diagram of digital, they will be asking block diagram of digital computer, so which we have already discussed. And next is memory. So they will ask you about memory. So when they are asking you about memory, specifically write about internal memory or primary memory, secondary memory or extended memory, cache memory and registers. So these are the 3 questions that can be expected from this class today. Thank you.